Hello everyone, I am Dr. Arun Sharma. In this video, I will explain hydrogen line spectrum. When an electric discharge is passed through gaseous hydrogen, the hydrogen molecules dissociate and the energetically excited hydrogen atoms produced, which emit electromagnetic radiation of discrete frequencies. The hydrogen spectrum consists of several series of lines named after their discoverers like Lyman, Balmer, Paschen, Brackett and Pfund. In this video, I will explain about the hydrogen line spectrum. Here, two types of the spectrum. In my previous video, I explained about the line spectrum, which of two types: atomic emission and atomic absorption. Line spectra is also called atomic spectra. So here, that is two types of line spectrum, that is line emission and line absorption, that is atomic emission and atomic absorption. First, I will explain about the atomic emission. Here, the atom which is considered, that is hydrogen. Either hydrogen atom is considered. The light emitted by a sample of excited hydrogen atoms can be passed through a prism and separated into certain discrete wavelengths. Thus, an emission spectrum, which is a photographic recording of the separated wavelengths, is called as line spectrum. Any sample of reasonable size contains an enormous number of atoms. Although a single atom can be in only one excited state at a time, the collection of atoms contains all possible excited states. The light emitted as these atoms fall to lower energy states is responsible for the spectrum. In case of atomic absorption, when white light is passed through unexcited atomic hydrogen and then through a slit and prism, the transmitted light is lacking in intensity at the same wavelengths as are emitted in case of atomic emission. The recorded absorption spectrum is also line spectrum and the photographic negative of the emission spectrum. So the atomic absorption is just like the photographic negative of the emission spectrum. So this is about emission spectrum and absorption spectrum of hydrogen. In case of emission spectrum, hydrogen gas at a low pressure is taken in the discharge tube and the light emitted on passing the electric discharge is examined with the spectroscope. The spectrum obtained is called the emission spectrum of hydrogen. The light emitted by a sample of excited hydrogen atoms can be passed through a prism and separated into certain discrete wavelengths. Thus, an emission spectrum, which is a photographic recording on the separated wavelengths, is called the line spectrum. Absorption spectrum: when white light is passed through unexcited atomic hydrogen and then through a slit and prism, the transmitted light is lacking in intensity at the same wavelengths as are emitted in case of atomic emission. So the recorded absorption spectrum is also line spectrum and the photographic negative of the emission spectrum. Here, the Rydberg formula, the Swedish spectroscopist Rydberg noted that all series of lines in the hydrogen spectrum could be described by this expression. Rydberg formula, which is used to calculate the wave number of all series of lines in the hydrogen spectrum. So this is mu bar. This formula is mu bar is equal to 109,677, that is 1,09,677 multiplied by 1 upon n1 square minus 1 upon n2 square centimeter inverse, where n1 is the orbital 1, orbital 2. So this is the first orbital and n2 is the higher than the n1. So n2 is the higher energy state and n1 is the lower energy state. The value 1,09,677 centimeter inverse is called the Rydberg constant for hydrogen. So the first 5 series of lines that correspond to N1 equal to 1 for Lyman, 2 for Balmer, 3 for Paschen, 4 for Brackett and 5 for Pfund series. So this is the series Lyman, Balmer, Paschen, Brackett and Pfund, which depends upon the value of N1. So these are the spectral lines for the atomic hydrogen. Lyman series, for this series N1 value is 1 and the N2 value is more than 1, like 2, 3, 4, 5, 6, 7, etc. And the Lyman series comes in the ultraviolet spectral region. For Balmer series the N1 value is 2 and the N2 value is more than 2, like 3, 4, 5, 6, 7. It cannot be less than N1 or not be equal to N1. And the spectral region for the Balmer series is visible. For the remaining 3 series like Paschen, Brackett and Pfund, the spectral region is infrared IR region and the N1 value is 3, 4 and 5 respectively for Paschen, Brackett and Pfund series, and the N2 value is more than the value of N1. So this is the transition of electrons in the hydrogen atom. This diagram shows the Lyman, Balmer, Paschen, Brackett and Pfund series of transitions. So here, as you can see that in this diagram, the N1 value is 1. This is the ground level of the energy state, and the value of energy is increasing when the value of N is increases, like 2, 3, 4 and 5, 6, 7 respectively, and at infinite times the value of energy is also increases. So when the excited hydrogen atoms comes to the lower state, they will emit the ultraviolet radiation because of the large energy values, large band gap. So it will appear in the ultraviolet region as in case of Lyman series, but in case of the visible Balmer series, it will appear in the visible spectral region. And here you can observe that red, green, blue and violet color are observed. Violet color is for the high energy and the red color is obtained for the lower energy, because the transition for the violet color is from energy level 6 to energy level 2. So the gap between the energy levels is high, so the frequency is also high, and for the violet light the frequency is higher as compared to the blue, green and red color radiations. In case of the red color region, the transition occurs from third excited state to the second excited state, second for the Balmer series, and due to this less gap, wavelength is high and the frequency is less, so we get the red color radiation. For Paschen series, the value of N1 is 3 and transition occurs from the 4, 5 and 6 energy levels. So this kind of transitions we have observed, and the Paschen and Brackett and Pfund series will appear in the infrared spectral region. So emission of radiation, that is the energy is emitted if the electron moves from higher orbit to the lower orbit, and the absorption of radiation, that is energy is absorbed if the electron moves from lower orbit to the higher orbit. So please subscribe this channel for more videos. If you have any questions, please feel free to contact me. Thank you very much.